Hello grade 10, it's Miss OD here again. Today we're going to look at solving exponential equations using logarithms. Now, when we did the indice part of this unit, or the exponential part of this unit, you looked at questions like question 1. So we'll just do a quick revision of those types of questions. Then we're going to do 3 different examples where we need to use a slightly different technique. So if we start with question 1 here, when we have exponential equations, and particularly if we have an exponential on both sides, like we do here, 4 to the power and 8 to the power of x. So we need to look at the bases here, and we need to decide, can we write both of these numbers in terms of one number as an exponential where they both have the same base? So we know that 4 is 2 to the power of 2 and 8 is 2 to the power of 3. So straight away I could rewrite that 4 as 2 to the power of 2, leaving the exponential part exactly the same for the moment. And then the same on the right hand side. I'm just going to write the 8 as 2 to the power of 3 and leaving that to the power of x. Now I can use another exponential rule. I have a power inside, power outside, so we use the multiplication rule. So I can multiply it. Now don't forget to multiply both parts of this exponent. So I have 2 to the power of 2x plus 2 to the power of 2 equals, and we can do the same sort of thing in the denominator here, just multiplying because there's a power inside and outside the bracket. So we now have 2 to the power of 3x. Then what we need is, because we need them both to be 2 to the power of. At the moment, this is not 2 to the power of by itself. We have this, of course, a fraction. So then we need to use another exponential rule. We use the -1. When it's 1 over an exponential, you can just rewrite that as a negative exponent. So that becomes 2 to the power of -3x. And of course, you need to just remember that and recognize that. And now, because the bases are the same and these two things are equal, the exponents have to be the same. Those two exponents, for it to be a true statement, for them to be equal, the exponents have to be the same. So now we can just create a very simple linear equation to solve. So we'll have 2x plus 2 equals -3x. And then I'm going to add 3x to both sides. So I get 5x, and while I'm at it, I'm going to subtract 2 from both sides. So I have 5x equals -2, and then just dividing both sides by 5, so x equals -2/5. So you've already seen ones like this. This is just a bit of a review. So now if we look at it looks very similar, this question, number 2. The problem is, our bases are 3 and 5. Remember, of course, this is 5 to the power of 1. But there is no way we can write 3 as a power of 5 and vice versa. We can't write 5 as 3 to the power of anything. So the technique we used here in question 1 is not going to work this time. So now we need to use a different technique, and this is where our logs come into play. And what we can do is, just like with anything in maths, as long as you keep it balanced, you can do anything to both sides of an equation. You know, we divided both sides of the equation by 5. We also subtracted both sides of the equation, subtracted 2, from both sides of the equation. So as long as you do anything to both sides of the equation, it's okay, it keeps it balanced. So what we can do is we can take log of both sides. Excuse me. Now, it doesn't matter which base, but because you're going to use your calculator, easier just to use log base 10. Now remember, if it's base 10, we don't need to actually write the base in. So I'm just literally going to put a log in front of 3 to the power of x and a log in front of the 5. So we're taking log of 3 to the x and we're taking log of 5. Then we need to use one of our log rules here, because we're trying to make x a subject, just like we did over here. We were trying to make x by itself. So we use our log rule that says that if we have a power, the rule says we can bring that power, we can bring that power down the front of the log there. So I can rewrite that as x log 3. And of course, we don't need to do anything with the right-hand side just yet. So that's going to equal log 5. And then remember log 3, log 5, they're just numbers. We can put them in our calculator and it'll give us a decimal. So this is x times log 3. So I want x by itself. So I'm going to divide both sides by log 3. Log 3 over log 3 is just 1, just like any time we have something divided by itself. So I'll get on the right-hand side though, log 5 divided by log 3. Now, if you want, you could leave it. That's the exact answer. However, what we can do is we can then use our calculator to get this answer. So I'm going to use my fraction button, alpha y equals, and then just enter. And I can then just put it in as it is. Now, be careful here. Make sure you use the log button, the LOG button. That's base 10. So you just literally type in log 5, and then in the denominator, log 3, and press enter, and we get a decimal. So we can see if we round to 3 significant figures here, we count 1, 2, 3. The next number's not 5 or bigger, so it literally rounds to then 1.46. So we see that that is approximately equal to 1.46. And that's it. That's all you have to do. So always look to see if you can use this technique first. See if you can make the bases the same. Particularly if you're not allowed to use a calculator, then you're probably going to have to use this technique, unless you leave this in exact form, of course. You're not expected to know what log 5 divided by log 3 is off by heart. Please remember, you cannot just cancel out the logs. It doesn't work like that. It's the same as trig. If you have sine 60, it means you have to actually take the sine of 60 first. Sine by itself means nothing. It's the same with a log. It means nothing if it's just by itself. So you must take that log 5. It's one whole thing. Therefore, you cannot just cancel the logs out. All right, let's try another one then. We'll just move this down. So this is the same idea, number 3 here. If we look at the base, we have base 4, and remember, of course, that could be 10 to the power of 1. 4 cannot be written as 10 to the power of anything, and similarly 10 cannot be written as 4 to the power of anything. So we need to use the technique of taking the log of both sides. So we literally just say log of 4 to the power of x equals log 10. Then we want the x by itself, so we bring that x down the front just using that power log rule. So we have log 4. Now, something interesting we can do here, remember there is actually, even though it's not written there, it's log of base 10. And we've briefly spoken about this. When you have log of something that is the same as the base, it actually is just 1. So we could, you don't have to because you're going to use your calculator anyway, but we could just write that log base 10, log of 10 base 10 as just 1. But of course you can leave it as log 10 because you'll need to use your calculator anyway. So making x by itself, remember it's x multiplied by log 4, so we're going to divide both sides by log 4. And then again, you could leave it as it is, that's your exact answer. Or we get an approximate answer using our calculator. Let's just clear this. And I'll go alpha y equals and enter to get the fraction 1 over log 4. So it looks like how we wrote it. And we can see here, rounding to 3 significant figures, count from left to right, 1, 2, 3. The next number's not 5 or bigger, so we can just chop it off. So we end up with approximately 1.66. Remember, this is an approximate answer. Even if you wrote all of those decimals out, it's still not exact. This is the only exact answer. So it's approximately 1.66. Okay. Right, let's try one more. So now we have, let's use black. This is question 4. 2 to the power of x minus 1 equals 13. This minus 1, just treat it like you would with a normal equation. Let's try and eliminate any constants that are there. So we can just add 1 to both sides. So we've got 2 to the power of x equals 14. Again, we have the problem. 14 cannot be written as 2 to the power of something there's not a nice whole number anyway. So we can't use the same technique as question 1. So we have to take the log of both sides. So we take log of 2 to the power of x. Don't forget to take log of the right hand side as well. You have to keep it balanced. And then we use our rule, bring the power down the front, just using our power log rule. So we'll have x log 2 equals log 14. And remember, it's x is multiplied by log 2, so we divide both sides by log 2. So we have log 14 divided by log 2. The other thing you need to remember, you cannot divide the 14 and 2. Again, this log 14, it's one whole thing. You have to do that, treat it as one thing. Log and the 14 are not separate, so you can't do any sort of cancelling there. So you can stop here, this is your exact answer, or we can go to our calculator to get an approximate answer. So we'll clear that. Let's get a fraction key, alpha y equals, enter. Then we have log 14, and arrow down, over log 2, enter. So we can see here, if we go 3 significant figures, we count from left to right, starting at the first non-zero digit, 1, 2, 3. Now this time the next number is bigger than 5, so we need to round that 0 up to 1, so it becomes 3.81. So that's an approximate answer, remember, 3.81. So that's how you solve log equations if you cannot write both sides like we did here as the same base. Okay, good luck with the rest of your questions.